Well, I might never get there, but I'm gonna try. Spend 10,000 hours for the rest of my life.
Do you love the rain? Does it make you dance when you jump with your friends at a party? What's your favorite song? Does it make you smile? Do you think of me? When you close your eyes, tell me what are you dreaming? Everything I wanna know it all. I'd spend 10,000 hours, 10,000 more. Oh, if that's what it takes to learn that sweetheart of yours. And I might never get there, but I'm gonna try. If it's 10,000 hours or the rest of my life, I'm gonna love you. Do you miss the road that you grew up on? Did you get your middle name from your grandma? When you think about you forever now, do you think of me? When you close your eyes, tell me what are you dreaming? Everything I wanna know it all. I'd spend 10,000 hours and 10,000 more. Oh, if that's what it takes to learn that sweetheart of yours. And I might never get there, but I'm gonna try. If it's 10,000 hours or the rest of my life, I'm gonna love you. I'm gonna love you. Oh, want the good and the bad, everything in between. Oh, gotta cure my curiosity. Oh yeah, I'd spend 10,000 hours and 10,000 more. Oh, if that's what it takes to learn the sweetheart of yours. And I might never get there, but I'm gonna try. If it's 10,000 hours or the rest of my life, I'm gonna love you. I'm gonna love you. Yeah.
Oh, all right, I think that's everybody. Get rid of that. Today we're going to start chapter 9. You should have seen in your grade book that I got chapter 8 test finally graded. It takes. I will forever appreciate paper tests now that I'm trying to grade stuff over digitally. So it goes much quicker using paper actually, which is kind of surprising. So anyway, we're going to get into chapter 9 here, which is polar. Um, and it's kind of the last topic that we really need to discuss to give you a good foundation for calculus BC. AB doesn't really cover this topic. So here we go. This is section 9.1. In a polar coordinate system, the origin is fixed point O. Admit, all right. Is a fixed point O called the pole. And really, I probably should show you polar graph paper right here. This is polar graph paper, and we're going to graph this later, but it doesn't delete when I clear the ink. So you have the pole right here, and that's what they're talking about right in the middle. And it's kind of like latitude and longitude. So they're calling that O. The polar axis is an initial ray from the pole, usually horizontal and directed towards the right. Which they're saying that this is a lot like unit circle talk, where when you're going to measure the angle, you start over here to the right, and then we measure the angle going positive angle going counterclockwise, and they'll mention that here in the reading. The location of point P in the polar coordinate system can be identified by polar coordinates of the form R, which is what circle are you on? In other words, what is the radius that you're on? So over here we see like 4 and then negative 120. Well, this is the circle we're on, and then this is the angle. And with those two things, you can locate a unique point. Where r is the directed distance from the pole to point, and theta is the directed angle from the polar axis to OP. To graph a point given in polar coordinates, remember that a positive value of theta. So a positive angle indicates counterclockwise, just like unit circle. Rotation from the polar axis, while a negative value indicates clockwise rotation. If R is positive, then P lies on the terminal side. So if P is positive, let's say you have 3 and 30 degrees. So here's 30 degrees, and it would lie on the third circle. So if you don't have polar graph paper, this is how you can graph these. Just draw it like that, where it'd be a circle of radius 3, and then at 30 degrees like that. Then they're saying, well, if R is negative, P lies on the ray opposite the terminal side of theta. So then if we have negative 30 degrees, we're going 30 degrees, but then in the opposite direction. So that would be, if this is point A, that'd be point A. This is B, that'd be point B. The negative 3 just says go in the opposite direction of the angle that is given. So we're going to practice this with some polar graph paper. Graph each point. All right, so negative 2, 30. So we're going to go to 30 degrees. Here's 30 degrees. Here's 45 degrees, and this up here is 60 degrees. These are actually 15 degrees, but we don't know much about 15 degrees. Anyway, I need to go 30 degrees. We need to go this way, but then in the opposite direction. So back to right here. This would be negative 2, 30 degrees. That would be point A right there. All right, we need to be on the fourth circle, a circle of radius 4, but then negative 120 degrees. So we have to be on the 1, 2, 3, fourth circle. There would be 90 and another 30. This would be point B right there. 1, 2, I'm way off, aren't I? 1, 2, 3, 4, right here actually. Forget that. B. Oh, I didn't count the, never mind. And then 4 and pi over 6. Well, 30 is pi over 6, and we're on the fourth circle. A circle of radius 4. 1, 2, 3, 4 again, right there. So we can do radians as well. It doesn't have to be degrees. Find 4 different pairs of polar coordinates that name point T if we're between negative 360 and 360. Well, let's see. We're on 1, 2, 3, 4, 5, 6, 7, 8. We're on a circle of radius 8. So we should be able to get a positive and a negative angle with 8. And we should be able to get a positive and negative angle with negative 8. So that's the 4 points, 4 ordered pairs that we could have that would describe T. 2 with positive and 2 with negative. So let's do 8. Let's go to this point, but go in a positive angle. So let's see, that would be, there would be 90 degrees. And then this would actually be, let me put it this way, this would be 15 degrees short of 180. So if we're going to go in a positive angle, that'd be 165. So there's a positive angle with a positive radius. But we can also get to that positive radius going backwards. So we can go this way. We can go 108, negative 180, and another 15 is negative 195 degrees. So 180 plus another 15. So there's the positive going forward and backwards. Now we can also go to this over here. 1, 2, 3, 4, 5, 6, 7, 8. Right. Now let me count that again. 1, 2, 3, 4, 5, 6, 7. Yeah, right here. This would be the opposite side of T, right? So we're looking at negative 8. So now we should be able to get to this angle in a positive and a negative direction. So the negative would actually be a little quicker. This would be negative 15 degrees. So if we go negative 15 and then negative 8 would tell you go opposite direction. So negative 15 degrees. Well, we should be able to get to that angle in a positive direction also. We should be able to go counterclockwise all the way to this. Well, that's 15 degrees short of 360. Was that 345? 300 negative, no, positive. That's right. So for every point that we have, you should be able to have 4 ordered pairs to describe that point. And the process is 2 positive radius, 2 negative radius. And you should be able to get there by a positive and a negative angle. And once you practice that a couple times, it's really not that bad. And then down here at the bottom right, we have graph the polar equations. Well, this says right here, this says the radius is 5. It doesn't matter what the angle is. The angle can be everything. So it ends up just being the equation of a circle. So 1, 2, 3, 4, 5. Drawing a circle with this tablet is not fun, but it should be this perfect circle going around there. There is r is equal to 5. So if you want to see it really nice, there we go. That's what we're looking at, that circle right there. Now, on when it says theta is equal to pi over 4, they're just talking about the angle. And the radius now can be anything. So pi over 4 is 45 degrees. So the radius can be 0. The radius can be all positive values. So this ends up being a line. It can be all positive values, and the radius can be all negative values as well. So we're going to go back this way. So it's really theta equals pi over 4 is the same as the equation y equals x. Same thing in rectangular. So anytime you have r equals something, that's going to be a circle. Circle. Looks like gurgle. Circle. And anytime you have theta equals pi over 4 or whatever angle, that's always going to be a line. Any questions? If you got it, type in the chat or unmute yourself, whatever you have to do. We'll move on to the distance between 2 points. So this is the distance formula in polar, and it's really the law of cosines if you look really close. If the point 1 is r1 theta 1 and point 2 is r2 theta 2, or 2 points in the polar plane, then the distance is given by that equation, which is really, it comes from the law of cosines. So find the distance between A and B. So we have a radius of 3 and an angle of 38 degrees, and a radius of 10 and an angle of 124 degrees. So the distance is the square root of 9 plus 100 minus 2 times, because we got r1 squared plus r2 squared, and then 2 times 3 times 10. I'm just following this formula up here. And then cosine of, and now we're always going to take the second angle minus the first angle, always second minus first. So 124 minus 38. Well, on your calculator, now we're doing this in degrees. So that means the calculator has to be in degrees. So I'm going to check the mode. I'm in degrees now, which is good, which is what I want to be in. So we have 9 plus, I should do square root, I guess. Square root of 9 plus 100 minus 2 times 3 times 10. Cosine of 124 minus 38. Notice I'm making the calculator do all the work. And so about 10. So the distance is 10.238 rounded. Find the distance between A and B. So we're going to do the same thing on this one. We have 36, which is 6 squared, plus 16, which is 4 squared. So these two values here. Minus 2 times 6 times 4. And then cosine of second angle, 11 pi over 12, minus the first angle, pi over 3. But now we're doing radians. So the mode, I have to have radians. And the only reason that I have to switch this mode is really because we're hitting cosine. If you have to hit the sine, cosine, or tangent button, then you have to pay attention to what mode you have to be in, radian or degrees. If you're not hitting those buttons, you don't have to worry about that at all. It's not going to affect your calculator in any way. So square root of 36 plus 16 minus 2 times 6 times 4, and then cosine of 11 pi divided by 12, and then minus pi divided by 3. Oh, did I forget to switch it? No, I did switch it. All right. Press enter, and I made a mistake, of course. That's minus. Oh, for crying out loud, you guys. 16 minus 2 times 6. Insert times. Was that it? Cosine. I think that's it. There we go. 8.026. 8.026 is what I get when you do the formula. That's it. I mean, for 9-1, the notes go pretty quick. I think there's a little bit more in 9-1, but this is all that we really cover. Plotting the points, knowing that there's 4 ordered pairs for every point, and then just being able to graph r equals 5, that is a circle, and theta equals pi over 4, that is a line. This little chapter gets more complicated than this, but 9-1 is pretty straightforward. So we have about 15 minutes left. So I thought we could just go through and maybe look at maybe some of the more difficult ones. How about number 2? If we go 330 degrees, that's 30 degrees short of 360. Here's 330 over here, but then negative 2.5. So 1, 2, negative 2.5. So this would be letter T right here. Now I sent you some polar graph paper. If you have the ability to print at home, you can print those out and use them for your homework. It makes the homework go a little smoother. But if you don't, no big deal. If you don't have the ability to print those out, this is how you would do it by hand. So you just make 3 of them, 3 circles, because you got to go to 2.5, and then just go backwards this way, and we'll count that good, and you'll just label that T. So if you don't have the ability to print them out, we're just going to, I'll just grade it as, just get as close as you can, and I'll be pretty lenient on that. So how about number 6? If we go negative 60, 1, 2, 3, 4, 5, and negative 60, then we're over here, right there. So that would be letter B. Yeah, how about one more on this? How about we do our radians? 3.5 and negative 11 pi over 6. So we're going all the way around 3.5, 1, 2, 3, all the way around to this would be negative 11 pi over 6, almost 12 pi over 6, almost 2 pi. So that's going to be 3.5, 1, 2, 3.5. Oh, I put this other one on 3. I wanted it on 2.5, didn't I? Right here. Oh no, wait. Which one did I do? 2.5. I wanted it right there. My apologies. That's T right there. Find 3 different pairs of polar coordinates and name the given point if we're between negative 360 and 360 or negative 2 pi and 2 pi. So let's try 15. We have the negative 2 and a positive angle. We have that. We could get negative 2 and a negative angle, 2 and a positive angle, and 2 and a negative angle. So there's the 3 other ones that we need to get. So let's find this spot. Excuse me, 300. So that'd be, this would be 2, 300. So we're actually over here. We're at negative 2. So at 300 and negative 2. So this is number 15. That's the point that we're trying to get. Well, we went positive to get this angle right here, to get 300. And now we could go negative 60 degrees. So negative 2, negative 60 would give us the same point. So we go negative 60, negative 2. That gets us to this spot right here. Now, what if we have a positive 2? This would be 90 and another 30. There's the positive. That'd be 120. And then we would have to go negative. So there'd be negative 180. And then we'd have to go another 60 degrees. So 240. So negative 240. So like I said, you can have 2 negative radii and 2 positive radii. And you should be able to have, for each of those, a positive and a negative angle. And so every single point should have 4 ordered pairs that you could get for every one of those. Graph each polar equation. Theta is equal to 225 degrees. If it says theta equals, that's a line. So I just have to find 225. That's 45 past 180. So that's actually right here. Here's the 225. And this would be all of the positive radii. We'd have a radius of 0, which is the pole, they call it. And then negative would be up here. So it's a line. But then if we have a radius is negative 3.5, it doesn't really matter that it's negative. The radius just happens to be 3.5. So 1, 2, 3. And so we'd have this circle right here, which circles are not easy to draw, especially on this little tablet that I'm using. So if you want it nice and fancy, 1, 2, 3.5. So about right there. That would be number 28, and that's a circle. Find the distance between each pair of points. What if we do, I think my calculator is still in radians. Let's try to get, I think your assignment's odd. That's all right. We'll try 31. We're going to try to get 10.7 out of this. So square root of 9 plus 64 is the law of cosine. So we're going to square those two. Minus 2 times 3 times 8. And then the cosine of, always take y2, or y2, the angle 2 minus the angle 1. I'm thinking y coordinates. It's not y coordinates, it's angles. 4 pi over 3 minus, not comma, pi over 2. Calculator. Square root of 9 plus 64 minus 2 times 3 times 8. And then cosine of 4 pi divided by 3, and then minus pi divided by 2. Pi divided by 2, and hopefully we get 10.7 out of this. There we go. 10.70 rounded to 2 decimal places. Find a different pair of polar coordinates for each point such that we're between 0 and 180 or 0 and pi. So if we grab number 44, 5 and 960 degrees. So I know we're on the fifth circle, 1, 2, 3, 4, 5. We're on this circle somewhere 960 degrees. And I'm sure there's a nice fancy way to do some division on this. But if you just go 960 minus 360, that gets you to 600. Minus 360, we're at 240. And then minus 360. And now we're at, 0 to 180. Why 60? $240. What am I doing wrong, you guys? Anybody got a chat for me? 960. Or minusing 360. Minus 360. Find a different pair. Oh, I gotta go negative. Yeah, I think someone probably told me that. Yeah, 5 to negative 5. Thank you, Ben. Appreciate that. Yeah, that's exactly right. So 240. Sorry, I'm not thinking very well. 240 would be what, right here? It'd be 60 degrees past it. But then if I went, all right, negative 560. There it is. Negative 560. Geez. Yeah. Anyway, that's what I got for you. Notes today. I should have a spot on Google Classroom for you to hand in the assignment. And yeah, we'll just keep on going. We got, what's today? Tuesday. We got 9-2 on Thursday. Fourth period. I have this fourth period as well. So we'll go 9-2, 9-2. And then we'll have a 9-1, 9-2 little quiz on Friday, just to kind of hold you accountable to keep studying this and know it. We'll try to keep those points low on the quiz. And yeah, that'll probably be due Friday at midnight, so you can just kind of get it over with and get it done. Any questions for the good of the cause? All right, you guys, make sure you're doing your homework. Make sure you're still turning it in. And if you have any questions, just shoot me an email, and I'll get back to you as soon as I can. Have a great day, and we'll see you again on Thursday. Bye-bye. See you guys.